You know, one of the biggest things holding AI back from being a true partner in our lives is its memory, or, well, its lack of one. So today, we're going to dive into this huge challenge of giving AI a memory that actually sticks and explore two radically different ways developers are trying to crack that nut. I'm sure we've all been there. You're having a great chat with an AI, you teach it something important like, hey, my birthday's next week, and then the very next day, poof, it has no clue what you're talking about. This goldfish memory problem, it's a universal thing, and it's all because of a fundamental bottleneck in how these models are actually built. The villain of our story today is something called the limited context window. The easiest way to think about it is like the AI's short-term memory. It's a buffer, and it has a fixed size. Once it's full, older info just gets pushed out to make room for new stuff. Now, this isn't a bug, it's baked right into the architecture. And figuring out how to get around this, that's the key to unlocking AI assistants that can actually remember who we are. So to solve this problem, two completely different philosophies have emerged. And this is more than just a debate about different ways to code. It's a fundamental argument about who should be in control of an AI's memory, you or the AI itself. All right, so let's meet the contenders. In one corner, we've got an approach that's simple, totally transparent, and puts you right in the driver's seat. And in the other corner, a super powerful but way more complex system that lets the AI manage its own memory all by itself. Yeah, this slide really lays it all out. You've got the transparent notebook, which is all about simplicity and you being in control. Think of it like a literal set of notes for your AI. Then you have the AI operating system, which is all about power and autonomy. A complex internal system that the AI manages on its own. These are two very, very different paths to the exact same goal. Okay, let's kick things off with the first approach. A great example of this is a super popular open source project called OpenClaw. Its entire philosophy is built on two things: simplicity and user control. And what's so cool about this is just how simple it is. Seriously, OpenClaw's memory is just a bunch of Markdown files sitting on your computer. It's got this two-layer system. First, there are daily logs for its short-term, working memory, and then there's a big memory.md file for the important long-term stuff you curate, like, I prefer writing in TypeScript, or we decided on a REST API for this project. And you can see the appeal right away, can't you? First off, data sovereignty. Your AI's brain lives on your machine, not some server in the cloud you don't control. It's totally transparent. You can pop open that memory file in any text editor and change it yourself. And it's efficient because it keeps those important long-term facts separate from all the day-to-day conversational noise. So how does it find the right memory when it needs it? Well, it's not just doing a simple text search. OpenClaw uses a clever hybrid approach. About 70% is semantic search, which is smart enough to look for related ideas, like it'll find dog when you search for puppy. And the other 30% is a classic keyword search for finding exact matches. This balance is great for pulling up context that's both relevant and precise. Okay, so now for our second contender, which, well, it goes in a completely different direction. This is the AI operating system. And a great example is a research project from UC Berkeley called MEMGP. This approach basically trades all that simplicity for raw power and autonomy. This quote from the research paper really says it all. The creators of MEMGPT looked at the operating systems we use every day on our computers for inspiration. I mean, think about your own laptop, right? It can run these huge programs with just a tiny bit of RAM because it's constantly, cleverly swapping data back and forth to the hard drive. MEMGPT does that exact same thing, but for an LLM's context window. The secret sauce here is this memory hierarchy. The AI's little context window, that's like your computer's RAM, super fast, but small. Everything else, all your past conversations, documents, you name it, gets stored in what they call external context, which is like a massive but slower hard drive. The AI itself acts as the operating system, deciding what to page from the disk into its RAM whenever it needs it. So what does this actually look like? Well, imagine a user casually mentions their birthday. The MEMGPT agent sees that and recognizes it as an important fact. It then, on its own, saves that fact to its working memory. And here's the kicker. The user didn't have to say, hey, remember this. The AI just knew to do it. And this is where you really start to see the power. Maybe days later, the conversation touches on a related topic. The agent proactively searches its own long-term storage, finds a connection, and pulls that context right back into the conversation. It makes the whole interaction feel so much more personal and aware. Okay, but this is the really wild part. What happens when life changes? The user mentions they broke up. The AI doesn't just add this new fact, it actively goes in, finds the old fact about their boyfriend, and replaces it to reflect the new reality. It's literally editing its own memory to stay consistent. It's a true black box managing its own internal world. So, after seeing all that powerful autonomous stuff from MemGPT, you might be thinking, well, that simple notebook thing sounds a little basic now. But hold on. It's evolving, and it's all thanks to the magic of open source. I mean, look at this. The growth of OpenClaw has been absolutely explosive. It started as one guy's weekend project, then it just went viral, attracting a massive community of developers. Within a month, it had its own conference. This thing isn't just a tool anymore. It's a whole movement that's pushing the simple notebook idea forward fast. And that huge community, they got to work fast, pointing out the weak spots of just using a basic Markdown file. Things like, memory getting forgotten in long sessions, or context from one coding project bleeding over into another. A plain text file can't really understand how concepts relate to each other, and it's tough to figure out where an answer even came from. And that's where the ecosystem really shines. Developers are building incredible plugins like Cogni and Moltbrain right on top of OpenClaw's simple file system. They add these new layers of smarts, like knowledge graphs that can map out relationships between ideas and powerful analytics tools, all while keeping your data local and you in control. It's transforming that simple notebook into something way more intelligent. So we've seen both sides, the simple, user-controlled notebook and the complex, autonomous OS. Which one is better? Well, like most things, the answer really depends on what you value most. All right, let's put them head to head and really break down these trade-offs. On the OpenClaw side, you get absolute control over your data and total transparency. You can see and edit every single memory. It's simple. Then you have MemGPT, which gives you this incredibly powerful autonomous agent that manages itself. But what's going on inside its memory is basically a black box. The choice really comes down to your priorities. Do you value data sovereignty and control, or do you need raw, autonomous power? And that really leaves us with the big question. As we're building these incredible tools, how should we think about their memory? Should it be a simple, transparent notebook that we own and curate ourselves? Or should we be aiming to build a complex, autonomous brain that learns, adapts, and even corrects itself, all on its own? The path we choose here is going to define our entire relationship with AI for years to come.